Guys, we are just quickly going to chat about this number 3, but I think you guys are probably okay because we had done a similar one before. All right, so they're saying a graph is plotted. Sorry, that's a bit blurry. I hope you guys can make that out. A graph is plotted of 5 people's age and height. Then they say draw this in your book. I mean, it's fine if you didn't. All right. You just had to basically answer those questions. Who is represented by each point on the graph? Okay, so again, the smallest one there is Jane, and it looks like she's a baby or a toddler or something. So Jane was C. Then the one that is a little bit older and a little bit taller than Jane would be Harry. So Harry was E. Then B and A, we can see that those two people are similar in height, but A and D are the same height, right? This is height, so A and D, sorry, I meant similar in age, not height there. A and D are the same height. Now, which two people have the same height here? Gary and Ian. So now we need to look at their age to decide which one is which, all right? So age, A is the one that's younger, D is the one that's older. I think we can assume from these pictures that Gary is older than Ian. So Gary is D, Ian is A, and then the last point B would have to be Fiona. Now we can see from here that Fiona is shorter, right? If we're looking at height, Fiona is shorter than Ian, but slightly older. Okay, if we're looking at the point, actually, we can see that she's slightly older than Ian. Sorry, there, these two. Right, so then the next questions were just about specific people. So who is the eldest? That was Gary. Which two people are about the same age? Fiona and Ian. Which two people are about the same height? Was Gary and Ian. And then E, we said you don't have to do of making up your own question. And guys, obviously we won't ask you to do something like that in a test or exam. That would be a bit extreme, right? But we could give you something like this, right? We've done 2 examples now where you have dots to represent certain people and you have to use that to label them. Okay, we find it's 3. Right, let's look at number 1, which was difficult. Okay, 1A, just see if you agree with those quickly. So for 1A, we spoke about B. Actually, I'm just going to show you the graphs first, then we can look at the answers there. We spoke about this one, right? This is where the depth of the water increases quite slowly at the beginning, but then the depth of water increases at a faster rate as it gets fuller. All right, so we went with this one. We said that beaker B would give you that relationship there because it starts wider, and as it becomes narrower, the depth will rise faster. Okay, so that was B. So number 1 was beaker B. Number 2, this one, that is the depth of the water is increasing at the same rate all the way up. What do we think? Which graph will have water that will, or the depth of the water that will increase at the same rate going all the way up? Joseph?
E.
E, right? Because it's the same width all the way up. Does that make sense? All right, if it's the same width, then the water is going to increase at the same rate all the time. Now this one is funny, right? It goes up and then it goes up again. Now guys, if we just look at this part, just hold on. It's increasing slowly at the beginning, then faster. Then all of a sudden it's again going slowly and then faster again. Okay. I just want to hear from someone else. Stella? D, I think D as well. Hey, because it starts out wide. Then as the beaker becomes narrower, the depth will increase faster. But then again, at this point, all of a sudden it's now wider again. So now it will again increase slower, and then as it goes up, it will increase faster again. All right, so I think that one is D as well. So what did we say here? This is B, that's E, that is D. Okay, now the last one. We have an increase at a constant rate, not a constant rate, but at the same kind of rate. All right. It's increasing quite slowly here. Do we agree? The slope is quite, just hold on. The slope is not very steep, but then it's increasing faster. All right. Then the slope goes up. Kitiwa, do you want to try? I think so too. Hey, do we agree with A there? All right, because it starts out wide, but it has the same width going up for that first portion. All right, so that is that bit. Where the width is going up at the same rate. But then here, all of a sudden now it's narrower. So now that part, as the water is being added there, will increase at a faster rate. All right, so that one is A. Okay, so that is what I wrote there, BEDA. Okay, now for B, they asked us for the other 4 beakers, we need to draw the graph. All right, so I haven't done that yet because I want us to discuss it before you actually see what it should look like. All right, so the first one that we didn't have, because we have A and B, that one is C. Guys, let's think about it. It starts out and it's quite narrow, right? So for the first bit, so here it's narrow. What happens then? It widens a bit, but then it becomes narrow again. So what do we think? What's going to happen to the depth of the water as it's being added? At what rate is it going to increase? Do we have the same width at any point here, right? Is it ever straight? So if we're looking at B and E, for example, those had straight parts. So then it would be a straight line. All right, so for this, it's a curved beaker. So we're going to have to use some kind of curve. What do we think at the beginning? Is it going to be fast or slow? Fast, because it's narrow. But then it's going to become slower. Slower, and then it's going to become faster again. Now, how could we draw that? A fast increase, a slower increase, a faster increase again. Okay, look at my finger. A fast increase, fast, then slower, then fast again. Okay, does that make sense? Let's see if we can do that. So fast, then it slows down, and then it picks up again. Something like that. Okay, that was a difficult one to start off with, so don't worry if you're a bit confused about that. But this is a fast increase, right? Then the rate at which the depth is increasing is slowing down, and then it picks up again. All right, let's look at the next one, beaker F. Beaker F look like this. Do we agree that this is actually the opposite of that one? Right, so we're starting wide, going narrower, then going wide again. So when the beaker is wide, the increase will be slow. Then the increase is going to pick up as it becomes narrower, and as it's going wider, it's going to slow down again. All right, so how do we draw it when it's slow? Like this, right? This is what a slow increase looks like. So it starts slow, it increases, then it picks up, and then it goes slow again. Okay, does that make sense? So we start slow, we pick up, and then we go slow again. So something like this. That kind of thing. Right? Sorry, I should have drawn it a bit bigger, but anyway, it's there now. Okay, so slow, there's the faster bit, and there it goes slowly again. Okay, let's look at G. I think, oh, this isn't the original. Sorry, I can't erase that. Just ignore those notches there. G, what's happening there? Starting out narrow, going wider. Right? When it's narrow, it is fast. So fast is like this. This is how we show a fast increase, right? So it starts out, we're looking at G, it starts out fast, and then as it's getting wider, what's going to happen to the depth, the increase in the depth? It's going to slow down. All right, so we're going to start fast and it's going to slow down. Is it going to pick up again? No, because it just stays wide. All right, so that one is a bit easier. We start off fast and then we slow down like that. Okay, H was an interesting one. And I want you to notice that we have straight edges on those 3 sections. Do we agree that that beaker has almost like 3 sections? All right, so our graph is also going to have 3 sections. But because the edges are straight going up, each section is going to be described or drawn using a straight line. What we need to compare, we need to make sure that when the increase is slower, the straight line is almost flatter. All right? Because when we did, let me just move it up. When we did A, remember that A was this one. Right, so A is similar to this graph. Sorry, A is this graph. Sure, that music is distracting me now. All right, this beaker is that graph. Do we see that H is similar to A? We just have an extra little bit there that we didn't have for A. So guys, for this first part where the beaker is quite wide, the increase is going to be slow. So it's going to be quite a flat straight line. Okay, so like that part, do we see that part is quite flat? The second part is narrower than the bottom part. So the increase is going to still be kind of at a constant rate. So it's still going to be a straight line, but it's going to be slightly faster. So it's going to be at a higher slope like we have here. But then for this top bit, it's very narrow. So the depth of the water there is going to increase very quickly. So again, it's going to be a straight line, but it's going to have a very steep slope. Okay, so we're going to use a ruler for this one. I don't have a lot of space, so I'm going to make them quite short. Let's say that's the first part. That is the second part, and then that is the third part. Right, does that make sense? So straight lines, but the slope is getting steeper as we go up because the rate of increase is going to become faster. Okay. Have you guys watched like the original Jurassic Park movies? Like the old ones? Okay, guys, I don't know, were you guys able to do these graphs on your own? Was it a bit difficult? Okay. Because I'm thinking maybe you should practice the swimming pool one now on your own, now that we've actually done these ones. Maybe it will be a bit easier to then actually do the swimming pool ones. Because after, we can look at the first answer quickly, but for number 2, they're saying here are the side cross sections of 5 swimming pools. All right, they're saying the pools are filled with water at constant rate, so just like the beaker one. You're again putting water into the swimming pools. For A, the graph shown is for one of the above swimming pools being filled. All right, one of these. Which one does it represent? So guys, this is a straight line. It's one with a constant increase. So which swimming pool do we think fits that one? Kitiwe? Swimming pool C, yes. All right, so to A, the answer there is swimming pool C. Then they said, just like in number 2B, you now have to draw a graph for each of the other swimming pools. All right, so you can see here, I was going to just discuss them with you again and fill them in as we go along. But I think if you struggled, right, or if you got all of these graphs wrong, please try to do these ones again. Just hold on, because I do want you guys to actually think about it on your own and see if you can get them right. Okay, so it was A, B, D, and E. E is on the side here. So you can just draw a graph for each of them. We actually still have, we can still mark a bit of work tomorrow, and then we'll start with data handling, which is quite a nice section. Should you guys do data handling in primary school? Like finding the mean, median, mode, that kind of stuff. Okay, all right, so we'll work on that. So that will be part of your homework for tomorrow. Stella, what was your question? Like these ones here. It might not look exactly the same, but that's the kind of concept that you're going. So for each of the pools, you must also draw a depth versus time graph. Guys, I just want to chat to you about the second half of this page, distance time graphs, right? I want you also to do A. You don't have to copy each graph. It says they copy each graph and describe the journey. All right, I don't want you to copy the graphs. Just look at the graph and figure out what is happening. If we're looking on the 2 axes, we have time and we have distance. So if we're just talking about the first one, guys, A1, what's happening here? As time passes, the distance is getting more. So what do we think? What's happening here? They're traveling somewhere. So what can we say about the speed at which they're traveling? Sorry, let me actually do this. Distance is equal to speed dst. Distance is equal to speed times time. Do we know this formula? Write that down quickly. Do you guys know that triangle? Should you learn it like that? The distance speed triangle, the DSTV triangle. Let me show you quickly. If you have a triangle, right? You can split it up into 3 sections like that. And then DSTV. So the V is now the upside down triangle, right? And then DST, like that. That's how you would remember how to put them in. Now guys, this is giving you 3 formulas actually in this one triangle. So the formula for distance is speed times time, because they're next to each other, right? But then if you wanted to get speed, it would be distance. And what do you think is happening here? Divided by time. All right, so that would be the second formula that you can get from there. And then time is distance divided by speed. I'm feeling a bit nostalgic hearing this. I'm thinking actually, I want you guys rather, sorry, I've changed my mind now. Let's not do A. Let's rather do B, because B is actually where you're going to have to use these formulas. They're saying copy the graphs onto squared paper. Please don't copy them. They are there already. All right. Find the speed for each of the following journeys. Now, guys, what is the formula for speed? Distance over time. So let me do the first one with you. Speed is distance over time. Now, if we're looking at this whole graph, what is the distance that was covered at the end of this journey? Distance is here, hey? 3 kilometers. Do we see that? When the journey was over, they had traveled 3 kilometers. So 3 over, how much time did it take them? How many hours? 2. So 3 over 2. You can leave it like that. What's 3 over 2 as well, though? 1.5, right? So the answer here is 3 over 2 or 1.5 or 1.5. You can decide how you want to write it. Kilometers per hour. Okay, so 3 over 2 kilometers per hour. Okay, that's all you're going to do for those ones. So for each of those, you're going to look at what distance was covered in how many hours. All right, distance divided by time, that is the answer for the speed. Okay, so don't do A, sorry, we've done quite a few of these now. Do B, please. So you're doing number 2, the swimming pools, those 4 graphs, and you are doing B on the second half of that page. Okay, we will mark that tomorrow. You can get going, guys. You can listen to music. If you have a test to study for, you can do so, but this work has to be done tomorrow. Yes. Sure.